conservation of energy. So what is the definition of conservation of energy? According to the principle of conservation of energy, energy can neither be created nor it can be destroyed. It only changes from one form to another form. It means that we can't create energy, we can't destroy a energy. We can convert a energy from one form to another form. If I'm talking about the mechanical energy, for example, mechanical energy is a sum of kinetic energy plus potential energy. Here M represent mechanical energy, K represent kinetic energy and U represent potential energy. So mechanical energy is a sum of kinetic energy plus potential energy. It means that these kinetic energy and potential energy are interconvertible. Means potential energy is converted into kinetic energy and sometimes kinetic energy converted into potential energy. For example, this ball is now having potential energy. Now it is moving downward, it is changes to kinetic energy. Again it is bounce back and moving upward. This kinetic energy of bouncing back is again changes into potential energy. But the sum of kinetic energy and potential energy remains same, that is a mechanical energy. So this is called conservation of energy. Here as this ball is moving down, potential energy keep on decreasing but kinetic energy keep on increasing. And as this ball is moving upward, now this ball is moving upward, potential energy keep on increasing and kinetic energy keep on decreasing. But one thing is conserved, one thing is constant, that is sum of both kinetic and potential energy, that is a mechanical energy. Clear? So here we will do a theoretical verification of K plus U is constant. Here K is a kinetic energy and U is a potential energy. So sum of kinetic energy and potential energy we will prove it as a constant for a freely fall body. It is a theoretical verification. Why it is a theoretical? Why it is not a practical? Because in the practical air friction is there, but in this derivation we are neglecting the air friction. So for this derivation you can write that we are taking it as a vacuum or friction, air friction we are taking it as 0. So ball at some height is having some potential energy, and when the ball is moving downward, potential energy keep on decreasing, and here initially ball is at rest, so kinetic energy is 0 and this ball kinetic energy keep on increasing. Okay, so potential energy maximum at is moving down. So here what will happen, whole potential energy is converted into kinetic energy. So let's see the derivation. For example, we have a ball which is at some height. Initially this ball is having a potential energy. Now what we will do, we will take three instant. First at the initial position, second at the middle and third at the ground. So we have took the three instances A, B and C. So these three instant we have, for example this displacement is covered as x, okay, and this whole height from the ground, this is h, and if this is h, this is x, so this is h minus x after subtracting. Now what we will do, we will calculate the mechanical energy at A point, mechanical energy at B point and mechanical energy at C point. For A, B and C point, mechanical energy is basically, mechanical energy we have sum of potential energy plus kinetic energy. So for A point, for point A, here we have potential energy as mgh. H we have this total H, okay, and at this point initial velocity is 0. If initial velocity is 0, kinetic energy at A point we have half mv square. So here initial velocity is 0, it means that initial velocity we will put it as 0. Okay, this initial velocity we will take it as 0 at A point. So here kinetic energy is 0. So now we have kinetic energy 0 and potential energy as mgh. So now what we will do, we will write it as m is equals to u plus u, here we have mgh, and k, kinetic energy, we have 0. So total mechanical energy we got it as mgh. Clear? So here total mechanical energy we got it as mgh at point A. Okay, so total energy at A point, we have kinetic energy 0, potential energy mgh. So total mechanical energy we have mgh. Now let's see for point B. For point B, or for instant B, here we have, this is x, this is h minus x, and this is total h. Here initial velocity is 0. For example, at this point velocity vb velocity, we have velocity at instant B. Clear? So now for the potential energy at point B we have at this point. What is the height from the ground? Height from the ground we have mg, height from the ground we have h minus x. Okay, so potential energy we got at B point is mg h minus x, and we have to calculate the kinetic energy at B, which is half mvb square, half mvb square. So velocity at B point we have to calculate. How we will calculate? By using the third equation of motion, which is v square minus u square is equals to 2as. So final velocity we have vb square, initial velocity we have 0, and 2. Acceleration due to gravity, because it is a free fall. So acceleration is due to gravity only, g. And total displacement from A to B point we have x. Okay, here it is important thing to note down that total displacement from A to B is x. Okay, so vb square we got it as 2gx. Now put the value of vb square here. So kinetic energy we have half m vb square as 2gx. So 2 and 2 cancel out. So kinetic energy we got it as mgx. Okay, now we have to calculate the total mechanical energy at B point, which is a sum of potential energy and kinetic energy. Potential energy we have mgh minus x. Okay, and kinetic energy we have mgx. Clear? Now we have to open the bracket, which is mgh minus mgx plus mgx. So here we cancel out mgx, and we got mgh. Clear? So mechanical energy at B point we got it as mgh. Clear this point? So here at B point we have kinetic energy as mgx, potential energy as mgh minus x, and total mechanical energy we have mgh. So now we have to do the same derivation for a C point. For point C, we have again this x, h minus x, and this is h. Now carefully see. For example, this here initial velocity is 0. Here we have to take, initially the ball is at rest. So we are taking initial velocity as 0, and final velocity we are taking as vc. Now first of all calculate the potential energy. Potential energy we have mgh. So what is h? This ball is on the ground, means very near to the ground. So here height is 0 from the ground. So height we are taking as 0. So potential energy at this point, at C point, we have 0. Now let's calculate the kinetic energy. Kinetic energy at C point we have half m vc square. Okay, so velocity at C point we have to calculate again using the third equation of motion, v square minus u square is equals to 2as. For example, from A to C I am calculating. So initially final velocity at C point we have vc square, initial velocity at A point is 0. 2. Acceleration due to gravity, again for example A to C, acceleration is due to gravity. And what is the displacement from A to C? Displacement from A to C we have this h. Clear? So vc square is equals to 2gh. Now put the value here, half m vc square. so which is 2gh. So from here 2 and 2 cancel out, so kinetic energy we got it as mgh. Now here we have to calculate the mechanical energy, which is sum of kinetic energy and potential energy. Kinetic energy we have mgh and potential energy we have 0. Okay, so potential energy at C point at the ground level, near to ground level, is 0. So mechanical energy at C point again we have mgh. So from this whole derivation what we got, that at each and every point, even though kinetic energies keep on changing, even though potential energy keep on changing, but sum of kinetic and potential energy, which is a mechanical energy, remain constant, which is mgh, mgh, mgh. Now carefully see, when the ball is moving downward, initially kinetic energy is 0 and at the end kinetic energy is mgh. So kinetic energy keep on increasing when the ball is moving downward, and at the highest point potential energy is maximum and at the lowest point potential energy is minimum. So when the ball is moving downward, potential energy is keep on decreasing, and the whole potential energy, carefully see this point, the whole potential energy, the whole maximum potential energy is converted into whole maximum kinetic energy near to the ground level. Means before touching the ground, the maximum kinetic energy in the body, it is equals to the potential energy initially it is having. So it is also called conservation of energy, in which whole potential energy is converted into kinetic energy. Clear?